Example 1, solving with addition. So let's go ahead and write the problem for example 1. Solve x minus 5 is less than negative 3. And then it's going to ask you to graph the solution. Let's go ahead and do this. And this is why we want to use those addition and subtraction properties because, again, the goal is to isolate the variable, isolate the x in this case. So, as always, rewrite the inequality. X minus 5 is less than negative 3. And my step right there was to rewrite inequality. Okay, and then my next step is to use the addition. So what is the smartest thing to add here to isolate the x? The inverse of negative 5, which is a positive 5. Add 5, cancel, add 5, find the difference, keep the sign of the larger. So therefore, it would be a positive 2. X is less than 2. We don't need to write that plus because it would be redundant. For my note-taking purposes class, we did addition. Remember, first name basis, addition prop. If that looks like prop of inequality. And then my last step was to simplify. 3 easy steps. I'm not going to take too much time on this because it is essentially the same thing as chapter 3. It's just a different sign. Okay. So your solution is x is less than 2. And now, hold up, you're not done. What did they ask? To graph the solution. Number line, do not grumble. You know how I feel about grumbling. So, let me go ahead and write a number line. It's nice that I have this graph paper that makes my lines fairly straight. I would do 0, 1, 2, 3. Remember, you're copying everything you see. Okay. And so I start off, I locate my number, which is 2. I locate it and I circle. Am I going to keep it open or closed, class? I'm going to keep it open because it does not have that under it. It does not have that equal to sign. And so now I ask myself, x is less than 2. Well, obviously, I know that everything to the left is less than 2. Everything to the right is more than 2. Right, more, left, less. Left, less. That's a good one. It's alliteration. LL, left, less. Okay, so then I'm going to color that in, put my arrow. This is graphing the solution. It's telling me that x can be 1, x can be 0, x can be negative 1, x can be negative 0.5, x can be anything along this line. Okay, sorry, way to go. Let's go ahead and try some on your own. See how quick this lesson is? Because the lessons build on each other. Okay, let me get my purple marker. You know what that means, on your own. Get ready to rumble. I want to see 3 problems. A, remember, solve the inequality and graph. Yes, and graph. Y minus 6 is greater than negative 7. B minus 3.8 is less than or equal to 1.7. Okay, and then C, negative 1/2 is greater than Z minus 1/4. Please read these out loud so you know which operation is going on. Pause it, solve it, and check back for the answer. Alrighty, class, way to go. I'm loving the hard work. So you should have gotten y is greater than negative 1 because you would have added the 6, and you know that's negative 1. And the way that you graph that is you keep it open because there's no equal to, and then you go greater than. Right is greater than. If someone can come up with a great alliteration to remember that right increases, please tell me tomorrow. Okay, and then the next one, B, you should have gotten B is less than or equal to 5.5. You locate 5.5, which is halfway between 5 and 6. It's less than or equal to, so you close it up because the solution includes 5.5, and then you go to the left, less. Okay, and then for C, you should have got negative 1/4 is greater than Z, or you can do the reverse as long as the sign is different, is flip-flopped, sorry, Z is less than negative 4. Okay, so you're going to locate negative 1/4, so right here, please don't get confused when you graph, don't get excited and just graph a 1/4, it's a negative 1/4. And we are going to keep that open because there's no equal to and less than, so we're going to go this way. I prefer to keep my variable first because it's easier to read, so I prefer this one. Z is less than negative 1/4. Awesome job. Way to go. You are done with example 1. Woohoo!